Hello everyone, and welcome back to my channel. And today we're going to be looking at proof by induction. I know this is the first video back in a while. I apologise for the gap in uploads, but we're back now. And I'm going to be taking through an example of proof of divisibility. So we're going to be proving, so the question is, prove that 8 to the n minus 5 to the n is divisible by 3, or rather 3 divides 8 to the n minus 5 to the n for all n belonging to the natural numbers. I think I read that right, yeah. Okay, so we're going to do the base case first. N equals 1, because that's the first natural number. So, 8 to the 1 minus 5 to the 1 is equal to 3, which is equal to 3 times 1. Therefore, divisible by 3. Divisible by 3. Okay? Apologies for the scrappy handwriting. Assume that 8 to the k minus 5 to the k is equal to 3m for some m belonging to the positive integers. I'm stating positive integers because natural numbers are all positive, so we need it to be positive, and we need it to be an integer. Assume that's true. That is just a fact now, based off our proof. And now we're going to consider n equals k plus 1. So n equals k plus 1, so that's going to be 8 to the k plus 1 minus 5 to the k plus 1. Which, first things first, we want to manipulate this so that our expression up here comes out into reality. So we have, therefore, 8 times 8 to the k minus 5 times 5 to the k. And I think some of you will be able to spot where we can take this out. So we have 5 total of the expression that we want to bring in. So we have 5 of 8 to the k minus 5 to the k. And then we have another 3 times 8 to the k, which means that we have 5 times 3m plus 3 times 8 to the k, which means we have 3 times 5m plus 8 to the k. So, true for n equals 1, or rather the base case. True for n equals k implies that n equals k plus 1 is true. True for n equals k implies true for n equals k plus 1. So, or rather, therefore, true for all n belonging to the natural numbers as it's stated in the question. And that's how you finish off a proof by induction or proof of divisibility. So yeah, little square and we are done. Thank you very much for attending this video, and I look forward to seeing you next time.